Hi, I'm Anna.
I'm Morgz.
And I'm Allie.
And we're testing the wave right at Allie Fair.
Some nights I stay up, cashing in my bad luck. Some nights I call it a draw. Some nights I wish that my lips could build a castle. Some nights I wish they just fall off. But I still wake up, I still see your ghost. Oh Lord, I'm still not sure what I stand for.
We want to figure out the average force of the water on the boat as the wave boat comes off the ramp.
We will use the impulse momentum theorem to figure this out.
The impulse momentum theorem states that an impulse on an object causes a change in momentum. To solve for the average force, we will use this equation. To figure this out, we will need to know the mass of the boat, the length of the boat, the time for the boat to slow down, and the initial and final velocity of the boat. The mass of the boat is 2,500 kilograms. The length of the boat is 5.72 meters. First, we will solve for the initial and final velocity.
To find the initial velocity, we counted the number of frames it took for the boat to travel its length before the wave began. Then we took that number and divided it by the number of frames per second to find the time. To find the velocity, we divided by length of the boat by the time. To find the final velocity, we used the same procedure as the initial velocity, only we started counting the number of frames after the wave had begun to fall.
I sold my soul for this. Wash my hands of that for this. I miss my mom and dad for this. No. When I see stars, that's all they are. When I hear songs, they sound like...
We figured out the change in time by counting the number of frames in between the initial and final velocity and dividing by 210 frames per second.
Next, we calculated the average force by using this equation. We calculated the change in velocity by taking the final velocity minus the initial velocity.
Therefore, the force equals 2,500 kilograms times 13.43 meters per second divided by 1.76 seconds. The force is 19,000 newtons.
So how many Morgz would it take to exert this force?
Morgan can exert 50 pounds of force.
50 pounds of force equals 222 newtons, so 1 Morgz equals 222 newtons.
In order to find how many Morgz it would take, we will divide the force by 222 newtons.
According to our calculations, it would take 86 Morgz to exert this force.